Hi dear student, we are going for the next concept in the colligative property, that is diffraction of a freezing point. It's very simple dear student. First to go for the freezing point of a compound. The freezing point of a liquid is that the temperature at which the vapor pressure of a substance in its liquid phase is equal to its vapor pressure in the solid phase. ಅಂದ್ರೆ ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು, ಕರಗುವ ಬಿಂದು ಅಲ್ಲ, ಕರಗುವ ಬಿಂದು ಅಲ್ಲ ಅದು. ಓಕೆ, ಐ ಡೋಂಟ್ ನೋ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ ಕನ್ನಡ, ದ ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಒನ್ ಥಿಂಗ್ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್, in this I'll start according to Rolle's law. We know that Rolle's law. What Rolle's law tells that when a non-volatile solvent or solute added to the solvent, you see here non-volatile solute added to the solvent, its vapor pressure will be decreases. Dear student. Then after that, from this we concluded that thus vapor pressure, thus the freezing point of the pure solvent will be decreases. ನೋಡ್ರಿ, ಇದರ ಮೂಲಕ ನಾವೇನು ತಿಳ್ಕೊಬೋದು, ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್ ಕಡಿಮೆ ಇರ್ತದೆ. ಓಕೆ, therefore vapor pressure decreases, the freezing point also decreases. Already we learned the relative lowering of vapor pressure. Whenever ನಾವು ಸೊಲ್ಯೂಟ್ ಅನ್ನು ಸಾಲ್ವೆಂಟಿಗೆ ಹಾಕೋಣ ವೇಪರ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಹಾಕೋದು ಕಲ್ತಿದ್ವಿಲ್ಲ, similarly whenever we are adding the solute to the solvent, the freezing point also decreases, dear student. That graph we have to observe here. I will draw the graph here. Okay, this is what a freezing point. Okay, temperature. Okay, 1 minute dear student, I will see what is that graph we observed in the previous session. Okay, this is vapor pressure like freezing point, and it is temperature. We first observed, we are getting to the curve like this. This is for the solute. Okay, this is for the straight line here, solution. For solution graph, these two curves are meet here, this will be meet here. Okay, understood? This graph will be, you see, observed then, and this is what, first this curve, this is TF, freezing temperature, and this is solution temperature. Okay, this is for solute and this is for the solution. Okay, first we go for the one by one. What is TF? TF not like similarly. Okay, dear student, it is not a temperature of solute, it is temperature of a solvent. Okay, it's the temperature of solvent and it is temperature of a solution. You see, this is temperature and this is delta, this is what TF. Okay, we'll go for one by one point first. The TF means this one. Hi dear student, this is TF means the freezing point of a solution. TF means freezing point of a pure solvent. Then after that, the change in the freezing point, that is, we know that delta TF is equal to TF naught minus TF. You see here, this freezing point of pure solvent is higher than that of solution. Then this one, this is called as what, KF. Sorry, this is what this is change in the freezing point. Then after that, this change in the freezing point, this delta TF is directly proportional to M, dear student. We remove this proportionality constant, delta TF equal to KF into M, where KF means what? KF means molar depression constant. The molar depression constant. constant, also called as what? Cryoscopic constant. Cryoscopic constant, dear student. What is mean by cryoscopic constant? I will discuss. I will write this. Okay. You see here, student, cryoscopic constant definition. It is defined as the depression in the freezing point produced when 1 mole of a solute dissolved in the 1 kg of a solvent. Same, dear student. It is like this one, which is that F, that this is what ebullioscopic constant. Similarly, ebullioscopic constant definition, dear student. Then go for the completion of this constant. Okay, this is dear what cryoscopic constant. This page over. You see, from this we know that the equation delta TF means change in the freezing point equal to cryoscopic constant into molecular mass, molar mass, where M means same W2 into 1000 divided by W1 into M2, dear student. This one substitute in this equation 1, therefore delta TF equal to KF into W2 into 1000 divided by W1 divided by W1 into M2, dear student. This is what a substituted value, dear student. If I want molecular mass M2, therefore this equation becomes 1000 into W2 into KF divided by delta TF into W1, dear student. You see this, if I want this M2, we have to simplify this one. This is what equation, this is what equation of the depression of the freezing point. Okay, it's very simple, dear student, and this equation very simple. I will tell you once again. The depression of freezing points means the depression of freezing point will similar to that whenever from Lord's law, whenever a non-volatile solute added to the solvent, the vapor pressure will decrease. If vapor pressure decreases, similarly the freezing point also decreases. From this graph, this is pure solvent. Whenever the solution graph, TF means the freezing point of a solution, TF naught means freezing point of a pure solvent. The change in the TFE means TF naught minus TF. Delta TF means directly the change in the freezing point directly proportional to M. If proportionality constant we are removing, we are taking KF. Then this equation delta TF equal to KF into M. M means we know that already. Yes, right. Therefore substitute this M in the above equation, it gets to the equation. This is what depression of freezing point, dear student. Okay, thank you for watching my videos. Okay.